And with this problem, we have 12 minus the absolute value of x. Now, you might recall from earlier days of algebra, when you learned about the absolute value of x function here, that you could break that up into two functions. So one for x being greater than or equal to 0, and the one being for x less than 0. For x being greater than or equal to 0, 12 minus x is just 12 minus x. Well, 12 minus the absolute value of x is 12 minus x, because the absolute value of x just behaves as x. However, for x being less than 0, the absolute value of x is the opposite of what x is, and so you get 12 minus negative x, or 12 plus x. So we're going to look at this in two different places. So we have in this, we have this side of the triangle, that area, and then this side of the triangle. The thing is, these triangles are symmetrical, and area of a triangle is 1/2 base times height. Our base is 12, our height is 12 for each of them. So 1/2 of 12 times 12 is 72. So we know the area of the triangle is 72. Now, let's take a look at this, this problem. We're trying to use the mean value theorem here. Switch back to blue. Okay. And the mean value theorem tells us that for that there's a value c such that f of c equals 1 over, this is the ends of our interval, 1 over 12 minus negative 12, interval from negative 12 to 12 of f of x dx. Now, something to look at with this, though, if we're going to break this up to two different intervals, we're going to have the interval from, so our f of, and notice here that c1 is less than c2, so c2 is the positive, c1 is the negative. F of c2 would be equal to 1 over 12 minus 0, integral from 0 to 12 of f of x dx. Well, we found that to be, I guess I can evaluate f of c2 now. That's the positive side, and we're looking at this here. So that's going to be 12 minus c2 equals 1 over 12 times 72. So 12 minus c2 is 1/12 times 72 is 6. Solving for c2, if I subtract 12 from both sides, negative c2 equals negative 6, so c2 must be 6. That's the value of c2. Now we're going to look at the other side of this, the negative side. If we're going to work on c1, our f of c1 is going to be 1 over 0 minus negative 12 times the integral from negative 12 to 0 of f of x dx. And we found what this is going to be here. We found that to be 12. So we have, in this case, 12 plus c1, because we're using this other function here, equals 1 over 12 times, and that area was 72. So 12 plus c1 equals 6. Subtracting 12 from both sides, kind of run out of space down here, c1 must be negative 6. And that's how we get the c1 and the c2.